Hi everyone, hope you're doing well. This is a video for lesson day 92, scatter plots and line of best fit day 3. So this is going to be the last day of any scatter plots or line of best fit teaching. So definitely, it's going to be a little more difficult since this is the last day. All these worksheets can be found on my website, and then don't forget to do your homework number 92 and post it on Google Classroom. All right, so here we go. So a little bit of stuff we've been doing, a little bit of new stuff, and some review from some functions unit. Okay, so here we go. Number 1, make a scatter plot from the data in the table. So we want to just label. We have X and Y. Don't forget your title. Simply just going to be X versus Y because these don't really stand for anything. And I don't really need to label this X and Y here because it's actually already labeled. So I want to go through all your points. So we have 0, 1. We have 1, 3, 1, 2, 2, 5, 3, 7, 3, 5, 4, 6, 4, 8, 5, 9, 5, 11, and 6, 12. Okay, so those should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 6, 7, 8, 9, 10, 11. All right, so we have 11 dots. Always wanted to just make sure. So now what we want to do is determine the equation, round to the nearest hundred. So again, exactly what we did yesterday, you want to choose your lowest x, and you want to choose your highest x. So what's nice is these are in order. Okay, remember it's not always going to be that way. Okay, so we want our equation, y equals mx plus b. We want the slope. We want the y-intercept. And we're going to use 0, 1 and 6, 12. So x1, y1, x2, y2. So we have y2 minus y1 over x2 minus x1. And that's going to be 12 minus 1 over 6 minus 0. So that's going to be 11 over 6. And let's see what that gets us. So 11 divided by 6. Remember, nearest 100. So you look to the third number. The third number 3 does not round this up. Okay, 5 or more, raise a score. 4 or less, let it rest. So we're going to let this one rest. So 1.83, 1.83. All right, now we want to figure out our y-intercept. So to be consistent, we're always going to use our first point and our slope from right here. So we always plug into y equals mx plus b. Y is 1, m is 1.83, and x is 0. So again, we're going to multiply, subtract, and we get 1 for b. Okay. Now, I just want to quick, before we go on, point one thing out, okay, because this hasn't happened yet, but I usually show a do now. Here, we had all these points that are consistent and kind of all together, and no outliers whatsoever. So, just in case this ever happens, if you ever do have a do now, and or any kind of question, and it happens to be where you have an outlier, remember the outlier is the one that's not near the other points. Okay, and this outlier happens to be your highest coordinate, like for this one it is. You don't want to choose that when going from your lowest to highest. So if your outlier happens to be your lowest x or your highest x, you just ignore that. So I wrote here, do not use the outlier when choosing the x values to make an equation. Okay, so I was going to do this do now or do this question here, but we don't have to. I can just show it to you. All right, because this doesn't really happen for you guys too much. This is more of like a high school thing. So again, make sure if you have an outlier and it happens to be your lowest x or your highest x, because what we're always choosing to make our equations, don't use that. Just ignore it, pretend it's not even there. Okay, so don't use the outlier when choosing the x values to make an equation. All right, so back to our question that doesn't have an outlier. So we now have our equation. Our equation is y equals 1.83x plus 1. 1.83x plus 1. Okay. So we made our scatter plot. We made our equation. Everything was to the nearest hundredth. And now we want to go ahead and draw your line of best fit. So remember, before begin, we need this equation to know where to start. So start here. So you want to go to 1, which happens to already be a dot, so that's really good. And you want to, again, put that trend line or a line of best fit right in the middle somewhere of your dots. So let's try here. And then I always count 1, 2, 3, I think it's kind of 4 above, 1, 2, 3, 4. Oh, pretty good. Okay, and now since this doesn't represent anything real life, you can have arrows on both ends. Okay, that is okay. So then write your equation, 1.83x plus 1. Okay, so now scatter plot's done. Equation is done. Line of best fit is done. So here's the new thing. Usually your part D is, I would say, you know, go to number 4, number 3, and interpolate and go up and over. But now I'm going to ask you to do what's called extrapolating. Extrapolating. Okay, so you're going to use your equation to extrapolate to figure out what y would be when x is 30. So y is just extrapolating. If you notice, there's no 30 here on my graph at all. 30 would be way over here. So it's not like I can go up and over and see where my line is, and you can't guess either, okay? So whenever you extrapolate, you're going to have to use your equation. So I was nice enough to tell you to use it, but sometimes they're not going to tell you to use it. You just have to know. So we're going to use our equation from above, and where x was 30, so right here where we see x, we're simply just going to plug in 30. And this is going to give us the approximate value of what it would have given us if we had our line and extended that far. So 1.83 times 30 is 54.9, and 54.9 plus 1 is 55.9, and that is your answer. So a little bit of review on that one, and then a little bit of the new stuff. All right, next question. Let's see what we have now. A history teacher asked her students how many hours of sleep they had the night before a test. The data below shows the number of hours the students slept and their score on the exam. Plot the data on a scatter plot. Okay, so we're starting off just like before. We need to need x and a y, add those. Those are already labeled, which is good. Don't forget your title. It's always your x versus your y. So number of hours slept versus test score. Okay. All right. Also, I want to point this out right here. This is just the way that this worksheet does it. Remember, this is that break, it's called. It allows you to go straight from 0 to 60. It's almost like an elevator. You just zoom right up to 60, and then you start doing your counting, so you don't have to fill in all the numbers. All right, so let's plot. So 8 and 83. 7 and 86. 7 and 74. 8 and 88. 676. 563. 790. 460. 89, and 781. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so those are our 10 dots. All right, so we plotted our scatter plot. Now again, determine the equation for the line of best fit, nearest hundredth. You always want to use your smallest and your lowest. Now be careful, just like your homework last night, these are not in numerical order. So you have to pick the right ones. Okay, so it looks like our smallest, I think, is 4, right? I don't see anything lower than 4. And it looks like our highest is 9. So those are the two coordinates we're going to use, okay? Remember, use lowest and highest x value. So that's how this unit differs from when we normally make our equations. All right, so we have y equals mx plus b, m equals and b equals, and then we'll get our equation. So our points are going to be 460 and 989. Again, our lowest x and our highest x. All right, so we do the same thing we keep doing. So we have y2 minus y1, x2 minus x1. That's going to be 89 minus 60, and then 9 minus 4. 89 minus 60 is 29. 9 minus 4 is 5. And we have 29 divided by 5, which is 5.8. And really, I guess it should be 5.80 because it does say nearest hundredth. I know science teachers are really picky with that. All right, so we want to use our first coordinate and then our slope to be consistent. Okay, so we plug into y equals mx plus b. So y is 60. Your slope is 5.80. Your x. And then we're going to multiply and subtract. So that's going to give us 23.2. And we subtract 23.2 from both sides because we're going to do the inverse operation of positive. And we're going to get 36.8. So we have a slope of 5.80. And we have I guess this technically should be 80 too. A y-intercept is 36.80. So our equation, put the m in here and the b in there and leave your y and x. So y equals 5.80x plus 36.80. If you don't have the zeros, it will not be marked wrong, okay? We are not as picky with the zeros as science. So we now have our equation. Remember, you want to, before begin, so you want to start here. Okay, so the next one, graph your line, you want to start here. Now here's why I chose this. I chose this question because we've never done a question where our y-intercept was in the break. So basically you're just going to approximate where you think 36.8 would be. So 30, so this is 0 to 60, right? So halfway would be 30, so maybe a smidge above that. And then you want to just make your line going through. And you're going to notice that it doesn't really look as nice. You know, normally you would think that the line would go this way. But because of this break over here, it's kind of messed up a little bit. So 1, 2, 3. 1, 2, 3, 4, 5, 6. Whoa, that's really off. Okay. So we erase. And we try again. Okay, so this time I got to go a little bit higher. I need some more x values or more dots on the bottom. So let's try maybe this. All right, so now I have 1, 2, 3, maybe 4. 1, 2, 3, 4. Oh, that works for me. All right, so again, you just keep erasing, and that's why, again, why we use pencil until you get it somewhere in the middle. So this is real life. So we do have an arrow on this side, no arrow here. No arrow, no negative hours or scores. Hours or test scores. Okay, but please make sure that you put the equation on that line. You don't want to get a -1. That would really stink. Okay, so let's see. We have our scatter plot. Everything was labeled. We did our equation. Here was our equation. We put the equation on the line. We graphed it. Arrow here, no arrow here. All right, so now we're down to part D. Is there a relationship? So this goes back to a couple days ago. Remember, relationship is the same exact thing as correlation or association. So this is like kind of like what you think of slope. You just follow like the pattern of the points. So these are going in a positive direction. So is there a relationship? Yes, it has a positive relationship. And then I want that sentence, remember, as the x increases, the y increases. So as the number of hours slept increases, so does the test score. Wow, that's really good. So they're saying if you sleep more, you will get better grades. I think that's a great idea. All right, moving on. Part E, last part. What would the student's test score be if they slept for 11 hours? All right, so let's see. Are we interpolating or extrapolating? So 11 is actually on my graph, okay? So I don't have to make any equations. This would be interpolating, because it's inside the plotted value. That 11 is inside this portion. So we can just actually go up and go over, and it looks like it would be approximately around a 95. Okay, now yours might be a little off. Maybe you got a 90, maybe you got a little higher, because it just depends on where you put your line. But my line tells me it should be around like 95. So if you can somehow get 11 hours of sleep on a night, it says you can get a 95. But all right, let's move on. All right, so the last 2 pages, so that's basically it for the scatter plots and line of best fit. So the last 2 pages brings in a little bit of what we did with our functions unit. You're going to see in a couple minutes, and then a little bit of what we're doing here. So the last part is called interpreting linear models. So you can use an equation to describe the trend line. Remember that also same thing as line of best fit on a scatter plot. The equation can be used to find relationships between the 2 data sets or variables that are being graphed. The slope of the equation describes the rate of change. Remember these fancy words, rate of change. And then the y-intercept describes the value of the dependent variable. Remember y-intercept we call initial value. So remember those fancy words from the function unit? Slope was rate of change, and y-intercept is initial value. All right, Lucia ships 8 packages from a delivery company. The weight of her 8 packages and the cost to ship them are listed in the following table. So you see all that here. Lucia creates a scatter plot of her data. She then draws a trend line. Again, remember, trend line means line of best fit through the data. So we see this data right here. Create and interpret the equation. Well, they kind of already give it for us, so we're just going to go through it. And definitely I would add an arrow here because you could keep going. So let's go through this. So the y-intercept, which is right here, is 5. The trend line goes up 1 unit for every 1 unit to the right. Therefore, the slope is 1. Lucia's trend line can be modeled by the equation y equals x plus 5, because your m is 1 and your b is 5. Y is the cost to ship a package. So hopefully you remember this word. Cost, remember that 3-letter word? That would be your fee, and that's going to be your initial value. So your initial value, we're going to bring back this word, fee. The slope of 1 means that the rate of change is $1 for every additional pound. The y-intercept of 5 means the delivery company charges a minimum of $5 to ship any package. So again, this is your fee. And you can always see the fee right here on the graph itself. And then I'll quick just go over and remind you how to do that slope part. So it basically is telling you that you go up 1 and right 1. Okay, so we kind of really don't need to figure that out. So what I would always do is I would have you write, I think I have you write this, change in y over change in x, which is 1 over 1. And then your y, is your money. And then your weight is your pounds. And then I had you kind of like set up something that looks like this. So it was $1 for every 1 pound. So I don't know if you remember me doing that from a little while ago, but that's what we're going to do on our last 2 questions in the back. We're going to interpret what these things actually mean instead of just coming up with numbers. All right, so 2 more questions. For questions 1 and 2, interpret the slope and the y-intercept of the trend line. Again, trend line means line of best fit for the situation. Then write an equation for the trend line. All right, number 1, the following scatter plot shows the prices and weights of several pieces of jewelry as well as a trend line. Okay, always have a 1 on the right, not on the left though. Interpret the slope, interpret the y-intercept, and slope, get the equation. So basically what you're going to do the equation first, because we kind of need to know what that is to even be able to interpret it. Okay, so we're going to be consistent, and we're going to try, if it's possible, to always use the lowest and the highest. Okay, so it looks like 1, 50, and then 8, 400. So just like the front, this is x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. So that's going to be 400 minus 50 over 8 minus 1. Okay, I don't like, let me write this way. So 400 minus 50, and then 8 minus 1. That's going to be 350 over 7, and 350 over 7 is 50. So we know the slope is 50. So why don't we interpret that now? So 50 is the same thing as 50 over 1, okay? Remember, it's the change in y over the change in x. Your y is money, and your x is ounces. So if we have our 50 over 1, so match them up. So 50 goes with the dollars, and 1 goes with the ounce. So that means your slope of 50 means it's $50, or it costs $50 per 1 ounce. Cost $50 per 1 ounce. Okay. Now for the y-intercept, you actually don't have to show any work because you could see right here that my y-intercept of 0. Okay, remember what that word means, that 3-letter word fee. So if it's 0, how much are they charging you? Well, there's no charge. So no charge for 0 ounces, basically meaning no fee. All right, our equation is y equals 50x. Remember, you do not have to put the plus 0, and then go ahead and put that over here. Okay, so y equals 50x. We got that from doing our lowest and our highest, our slope. You can also do rise over run if you wanted to. You'd have a rise from 50 to 400. That would be a rise of 350. And then from 1 to 8 is 7. So you get the same exact answer of 50, whatever you're comfortable with. All right, last question. The following scatter plot shows a plumber's charges and the time he spends at each job, as well as a trend line. Again, trend line just means your line of best fit, which is this line through the dots. All right, so it looks like we're going to do the same exact thing. So we're going to pick our lowest and our highest. Goes B equals. And our lowest is 0.5, and, oh, this is one a little hard to tell. Well, if this is 40, that means this is 60. Between 60 and 80, 60 and 80 is 70. So this is going to be 0.5 and 70, and 4 and 280. 4 and 280. Usually we try to use the dots that are exactly on the line so we know exactly what number it is. In the future, I'll make sure that these ones always work out so you can see that. But for now, we'll just assume that it is 70. So we have x1, y1, x2, and y2. So we have y2 minus y1, x2 minus x1. So 80 minus 70, y2 minus y1, 4 minus 0.5. And that's going to give us 210 over 3.5. Over 3.5, and that's going to give us 60. All right, so we know our slope is 60, okay? So we're going to do change in y over change in x. So your y is your money, and now your x is your hours. So our slope is 60. We're 60 over 1. 60 goes with the money, and the 1 goes with hours. So it means it's going to cost $60 per 1 hour. Okay, y-intercept, we don't really have to do any work. We already see that that is 40. Okay, so remember, what does that y-intercept mean? What does that charge? What's that fancy 3-letter word? Fee. So the fee, or we'll just write his fee, is $40, basically for just showing up. So for him coming to your house, showing up, it's going to cost $40. Okay, we put that together. Y equals 60x plus 40 is the equation. Please make sure you put that equation on the line. Okay, and again, you can do rise over run if you wanted to. You just go up from here and over. You could really even just use this point too if you wanted to, up and over. You'll get around the same thing. All right, hopefully this makes sense. Don't forget to post your homework on Google Classroom. Okay, your homework is going to be just like these questions. It's going to be plotting the points. That's your part A. Okay, just plot the points. You want to find the equation, still going to the nearest hundredth. Okay, so follow all the same steps for slope and y-intercept. Draw the line of best fit, so make sure it starts wherever your y-intercept is going to be. And then it says use your equation to find the number of representatives for a state that's a population of 11 million. Okay, so even though you can interpolate this, it does want you to use your equation, but those numbers should be around the same. And then when you're finding numbers for 11, oh, I just told the answer, but oh well. All right, have a great day.